Audio Jungle.
My dear students, how are you? I hope all you are well. In this pandemic situation, this is very crucial time. We don't know when we can meet, but I am missing my students and my lovely school campus of Milestone School and College. One thing that will inspire me very much now, that your like and comments in my videos, and I hope you will continue to give like and comment in my videos. That will inspire me for making good videos. So my dear students, let's start today's class.
Audio Jungle.
My dear students of class 6, today I am going to discuss chapter 2, ratio and percentage. That is the name of this chapter. At first, I will discuss some basic discussion, and then I will solve a math example number 1, that is CQ, and example number 3, and I will show you a video that will help you better understanding. At the end of this lesson, you will be able to explain ratio, explain equivalent ratio, explain simple ratio, explain ratio of less inequality, explain ratio of greater inequality, explain unit ratio, explain inverse ratio, explain mixed or compound ratio, solve example 1 creative question. So let's see again. Explain ratio, explain equivalent ratio, we will know simple ratio and unit ratio, inverse ratio, mixed or compound ratio, and at last we will solve example 1 creative question. Review of previous lesson. My dear students, this is the first class after the half-yearly syllabus. Today, I want to know from all of you, how was your half-yearly examination? I hope all you had done well. So, let's start today. At the beginning of this class, I want to show you a video that is related on basic discussion. Let us enjoy the video.
Ratio and its applications. In this module, you will learn about ratio, equivalent ratios, and some applications of ratio. Mom, I'm thirsty. Please make a glass of orange drink for me. Okay, Vinay. Wait, Mom. I want to see how to make it, so that I'll be able to make it for my friends when they come in the evening. Mom, how did you know what to add and how much? It is written on the bottle. To make a glass of drink, take 1 cup of orange squash. Pour it into a glass, add 3 cups of water to it, and then mix them well. Your drink will be ready to serve. Mummy, please make 1 drink for me too. Now, how will you add the squash and water to make the drinks for both of us? See, to make it for 1 person, we have to take 1 cup of squash and 3 cups of water. For 2 persons, we have to double the quantities of both the squash and water. That means we need to take 2 cups of squash and 6 cups of water. Think, if I have to make it for 3, then we have to take 3 cups of squash and 9 cups of water. Here, the quantity of water we have added is 3 times the quantity of squash. How did you find it out? If we divide the number of cups of water by the number of cups of squash, we get 3 each time. Mummy, it is denoting 3 times 1. Correct. You know, here you are comparing using ratios. What is a ratio? The comparison of 2 quantities in terms of how many times is called ratio. Here, the ratio of squash to water is 1:3, and it is read as 1:3. Using ratio, it is easy to calculate. How? The ratio of squash to water for 1 person is 1:3. If we have to make it for 2 persons, then multiply the ratio by 2. Then it becomes 2:6. For 3 persons, multiply it by 3. That is 3:9. Can you find how much squash and water is to be added for 10 persons? For 10 persons, I have to take 10 cups of squash and 30 cups of water. And I come to know by multiplying the ratio by 10. Here, for all the ratios we have found, we have added water 3 times of squash. That means the ratio is constant here. Such ratios, which are obtained by multiplying or dividing by any counting number, are equivalent ratios. 1:3 is its lowest form, as it can't be further divided. Correct. Now you get it. We have used the squash and water in the ratio of 1:3. For this, can you write the ratio of water to 1 glass of drink made? I think it is 3:1. No, Vinay, we can't calculate ratio in different units. Here, the unit for water is 3 cups. Then we have to use the same unit for the drink also. 1 glass of drink contains 1 cup of squash and 3 cups of water. That is, 4 cups are poured into 1 glass to make 1 drink. Yes, that is why the ratio of quantity of water to drink is 3:4. And for quantity of squash to drink, it becomes 1:4. So, while writing ratios, first we have to convert different quantities in the same unit. Let's recap. Ratio. The comparison of quantities in terms of how many times a quantity is of another quantity is called a ratio. Equivalent ratio. Ratios which are obtained by multiplying or dividing by any counting number are equivalent ratios. A ratio is a comparison between quantities in same measures or units.
So my dear students, hope you enjoyed the video. Now I will discuss the same thing, ratio. In mathematics, a ratio indicates how many times one number contains another. Let us see the example. If there are 8 oranges and 6 lemons in a bowl of fruit, then the ratio of oranges to lemons is 8:6 or 8:6. You have to call like 8:6. Similarly, the ratio of lemons to oranges is 6:8. Again, another definition of ratio for making you better understanding of 2 quantities of the same kind. One is how many times or parts compared to the other can be expressed by fraction. This fraction is called ratio of 2 quantities. Since the two quantities are of the same kind, the ratio has no unit. So example, Alam's weight is 30 kg and his father is 60 kg. How many times is the weight of father greater than that of Alam? Let's see the solution. Ratio of the weights of father and Alam is 60 kg divided by 30 kg equals to, if we reduce dividing numerator and denominator by 30, we will get 2 by 1. That is 2:1. That is our desired answer. So let's see again. That is the definition of ratio. That is another definition, and this is the example. And I hope you understand the ratio. This is our desired answer. The next one is equivalent ratios. Two ratios that have the same value are called equivalent ratios. To find an equivalent ratio, multiply or divide both antecedents and subsequent by the same number except 0. In here I am going to say you like antecedent is the numerator and subsequent is the denominator. So we can call as a numerator as the antecedent and denominator as a subsequent. It is the same process as finding the equivalent fraction. That is the example. As you can see, 2:5 equals to 2 divided by 5 equals to 2 multiplied by 2, 5 multiplied by 2. In here I am saying that the same number we have to multiply both antecedent and the subsequent, and the same number is 2 in here. We multiply with the subsequent and the antecedent also. So we get 4 divided by 10 equals to 4:10. So we can say 2:5 is equivalent to 4:10. Therefore, 2:5 and 4:10 are equivalent ratio. These are the process to find an equivalent ratio. So these are the things, equivalent ratios, a definition, example, and these two are the equivalent ratios. Simple ratio. The ratio of two quantities is called simple ratio. The first quantity of simple ratio is called antecedent and the second quantity is called subsequent. That is the thing I am saying. In a fraction, the numerator is called antecedent, that is called first quantity, and the denominator is called second quantity, which is called subsequent. Example, 3:5 is a simple ratio. Here 3 is antecedent and 5 are subsequent, and if we write to it in a fractional form, we can write it 3 divided by 5. Ratio of less inequality. If the antecedent is smaller than the subsequent of a simple ratio, the ratio is called the ratio of less inequality. Let's see an example. 3:5 and 4:7, both are the ratios of less inequality, because in here you can see antecedent, they are less than subsequent. So 3 is less than 5, 4 is less than 7. So we can say these two ratios are ratio of less inequality. So this is the definition and this one is the example. Now, ratio of greater inequality. If the antecedent is greater than the subsequent of a simple ratio, the ratio is called the ratio of greater inequality. Let's see the example. 5:3 and 7:4, both are the ratios of greater inequality because antecedent is greater than subsequent. As you can see, 5 is greater than 3, 7 is greater than 4. So you can say these two are the ratio of greater inequality. So this is the definition and the example. Unit ratio. The ratio in which the antecedent and the subsequent are equal is called unit ratio. Let's see the example. You can say 15:15 or 1:1. The antecedent and the subsequents are equal. So that is the definition and that is the example of unit ratio. Inverse ratio. by interchanging the antecedent and subsequent of a simple ratio is called inverse ratio. Example, 5:13 is the inverse ratio of 13:5. That is the thing. Subsequent will be in antecedent position and antecedent will be in subsequent position. That is the thing of inverse ratio. That is the definition and that is the example. Mixed or compound ratio. The ratio obtained by whose antecedent and subsequent are formed by the products of antecedents and subsequent of more than one simple ratio is called mixed or compound ratio. Let's say an example. The mixed ratio of simple ratio 2:3 and 5:7 is 2 multiplied by 5. That means antecedent multiplied by antecedent is 2. Subsequent multiplied by subsequent, that means 3 multiplied by 7. 10:21. That is our desired mixed or compound ratio. That is the definition and that is the example. 10:21 is our mixed or compound ratio. My dear students, now example number 1. There is the question ratio stem. The ratio of age of Jasmine and Abida is 3:2. The present age ratio of Abida and Anika is 5:1. The present age of Anika is 3 years 6 months. That is the given information. Number A, express the first ratio in the stem into percentage. Number B, what will be the Abida's age after 5 years? Number C, what is the present percentage of Anika's present age to Jasmine's present age? Let's see the solution of A. The first ratio of the stem is 3:2, as you can see in the stem. So the question is express the first ratio in the stem into percentage. What can I do? How can I do? Equals to 3 divided by 2, as I am saying. That is the 3:2. That means the fractional form 3 divided by 2. 3 is the antecedent and 2 is the subsequent. So if we multiply 3 with 100 and 2 with 100, there is no change of value. So instead of 100 of this subsequent, we can write down the percentage and 3 multiplied by 100 divided by 2. If we calculate it and if we reduce it by 2, we get 150%. That is the answer of A. Let's see solution number B. What will be Abida's age after 5 years? Present age of Abida is to present age of Anika equals to 5:1. That is the given information in the stem. It means Abida's present age is 5 times more than Anika's present age. That you have learned from the unit, from the ratio at first. Anika's present age equals to 3 years 6 months. As you can see in here, 3 years 6 months. So we have to convert these 3 years into the months. That will help us to solve this math easily. 3 multiplied by 12 plus 6. Why it is multiplied by 12? Because since 1 year equals to 12 months. That's why if we multiply 3 multiplied by 12 plus 6, that will get the full months. 36, 3 multiplied by 12, that would be 36 plus 6. So 42 months. That is the conversion of 3 years 6 months equals to 42 months. Abida's present age 42 multiplied by 5 months, because in here what I have written that it means Abida's present age is 5 times more than Anika's present age. That means it is Anika's present age and 5 times more. That's why if we multiply with 42 by 5, we get Abida's present age in months. So if we multiply 42 by 5, we get 210 months. So 210 months we got equals to, we have to convert these months into years, because at last we have to write down the answer in years. So if we want to convert 2 years, what you have to done? 210 divided by 12. Since 12 months equals to 1 year, that's why we will divide 210 divided by 12. That is, if we reduce, we get 35 by 2, and if we divide, we get 17 on divided by 2 years. So we have to find out the Abida's age after 5 years, because the question said what will be the Abida's age after 5 years. So we got it is the present age of Abida, and after 5 years Abida's age will be, obviously we have to plus 7 plus 17 plus 5. So 5 plus 17 and a half years. So we will plus the integer value first. We will get 22 on divided by 2 years. That means 17 plus 5, that would be 22 on by 2 years. That means 22 half years. So my dear student, let's see again, that is the stem of this math, and we need to find out the first ratio stem into percentage and Abida's age after 5 years. That is the solution of A. 3:2, we can write down 3 divided by 2 equals to 3 multiplied by 100 divided by 2 multiplied by 100, because there is no value change, but because of subsequent 100 we can write down the percentage, and after reducing we get 150%. Now it is solution number B, that is the present age, and from this ratio we know Abida's present age is 5 times more than Anika's present age. So we have to convert at first Anika's present age into months, that we get 42 months. Abida's present age 5 multiplied by 42, that is 210 months, and we have to convert it into years, that we get 17 and a half years, and after 5 years the age will be 5 plus 17 and a half, that would be 22 half years. That is our desired answer. My dear students, example 1, that is the question and stem. Solution of C. Age of Jasmine is to age of Abida equals to 3:2. From B we got Abida's present age equals to 17 and a half years, or 35 by 2 years. So with the help of Abida's present age, we got Jasmine's present age equals to 35 by 2 multiplied by 3 divided by 2, because in here you can say age of Jasmine is to age of Abida equals to 3:2. So if we multiply 35 multiplied by 3, that would be 105, and 2 multiplied by 2, that would be 4. And if we divide 105 divided by 4, we got 26 on by 4 years. So we already got Jasmine's present age is 26 on by 4 years. Anika's present age equals to 3 years 6 months. So if we convert these 6 months into years, how can we convert it? 6 divided by 12, because 1 year equals to 12 months. So if we reduce 6 by 12, what we get? On divided by 2. So 3.5 years equals to 7 divided by 2 years, because you know 3 into 2, that would be 6, plus 1, that would be 7 divided by 2 years. So we can write down now Anika's present age is Jasmine's present age equals to 7 by 2 is divided by 105 by 4. So 7 by 2 multiplied by 4 divided by 105, because if we multiply, that would, we need to do reciprocal. So subsequent will be in antecedent and antecedent will be in subsequent, as you can see in here. After that, if we reduce 2 divided by 4, that would be 2. 7 105 divided by 7, that would be 15. So if we want to make it in percentage, we have to multiply with 100 with the antecedent and the subsequent. As you can see, 2 multiplied by 100 divided by 15, and for the 100 of this subsequent we got the percentage sign. That is the thing I am telling you. So we get, if we reduce 15 and 100, we got 40 divided by 3%, and in mixed fraction that would be 13 1 by 3%. That is our desired answer. Let's see again. That is the stem, that is the question, and that is C number. That is the solution. Age of Jasmine 3:2. By the help of this we got Jasmine's present age, that is 26 1 by 4 years, and this time Anika's present age we have to convert it to years. As you can see, I am converting to years, and by the help of this Anika's present age is to Jasmine's present age, that is the desired percentage we made. So another example 3, that is the question, determine the compound ratio of given simple ratios. That is the simple ratios are, that is the solution, the product of the antecedent of the given ratios. As you can see, 5 is the antecedent, 4 is the antecedent, and 3 is the antecedent, so it is the product of 60. The product of the subsequent 7 multiplied by 9 multiplied by 2, that would be 126. Required compound ratio is 60:126, or if we reduce 60 by 126, we got 10:21 divided by 6. So that is our desired answer. Let's see again. That is the question, and the solution is, at first we have to do the product of antecedent, after that the product of subsequent, and that is our desired answer, 10:21. Let's see the summary of today's lesson. Ratio. A ratio indicates how many times one number contains another. Equivalent ratio. Two ratios that have the same value are called equivalent ratios. Simple ratio. The ratio of two quantities is called simple ratio. Unit ratio, the ratio in which the antecedent and the subsequent are equal, is called unit ratio. Mixed or compound ratio, the ratio obtained by whose antecedent and subsequent are formed by the products of antecedent and subsequent of more than one simple ratio, is called mixed or compound ratio. So that is the thing we have learned today. So today's HW from chapter 2, page number 52 to 53, you have to do as a HW example 4, 5 and 6. Enjoyed the class and understand everything very clearly. If you have any question, you can ask me in Messenger group class or in Zoom class, no problem. We will meet together again. We will meet in the next class. Thank you.